This is why we are making this circuit. You can see this board is capable of breaking the bricks into the multiple pieces and without losing their throttle and power. So this circuit is won in IIT Mumbai and with the first prize. Here you can see some of their uh, movements. These are the opponent and this is our bot. Okay, this bot is having a capability to move this 10 kg brick, and after all the fightings you can see our bot is keep hamming this bot, and now the bot is being drained too much of their battery with God, but our bot is wireless and keep on hamming and destroy their components. You can see there is a shake in the screen. Just hold on for a bit. This is the moment where the screen is shake. We destroyed their wheel with having a hamming of 10 kg with the 10 frames means 10 hits per second with the rotation of our bot. So we win the first prize in RoboWar. This is the size of our bot. This is the another video with having this circuit. This is the circuit with the I'll go again goes to the circuit. You can see the IC. This is ULN 2803, and these are two relay to move right and left motor with the speech recognition from a computer interface. Here you can see this now you can see the bot is moving by speech recognition, moving clockwise, anti-clockwise, back, forward, with having a weight of person nearby 60 kg and self weight of the wheelchair is 45 kg. Okay, let's begin with the circuit of high current rotation for motor. So here in a circuit we are using a mechanical switching relay for motors, because by a mechanical switching of the motor it may go with the very high current of the motor, and any of the voltage what we are taking uh, same as like in solid state relays or solid state H bridge connection, but there is a limitation of current and there may be some spikes or noise will be generated in a circuit, and it will give the feedback to the circuit if is in there any of the problem with the motor. So let's go with the mechanical switching. This is the best for the RoboWar circuits. So let's begin with the first circuit. Go for Proteus. I'll go with the Proteus Professional 8. So I'll go with the new circuit and name it with mechanical underscore HBRIDGE, mechanical H bridge. Okay, I'll go for default. Create a schematic for the selection template is default. I'll go with the default settings. Okay, and nothing to do with these things, and finish the circuit. Okay, here is the canvas. First we'll go and search for the relay mechanical switch and go for the generic one, and here you find the single pole with dual through output, the single pole two-way switch same as like. So there is another also, but having a 2 pole and 2 throws. We'll prefer with this one. Okay, just press here, just zoom it a bit with the scroll with the center of the mouse click and place it in there. Just rotate it with the plus sign in the keyboard, sorry, on the keyboard, same as like plus 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 on the keyboard, but we have to flip it. Go with this flip, and here we get the basic circuit for a design. Now connect a power supply. For a power supply we have to go with these terminal screen window. Here you find the ground, place the ground here, and also go for a supply. This is default generator where we find the DC output, and for this we are going to connect these terminals first. From there we will get the negative supply at this point when the relays get switched, same as like in this one. We get the negative from here, and whenever the switch is on, and this terminal is connected with this one, and we'll get the negative output from this point. So go with a DC motor from device. Yeah, just type it motor, MOTOR. There must be an active motor must be present in there. So here's the motor. Okay, motor with the DC motor model. I'll go with this, just plus sign on the keyboard and place motor here. Connect this with this terminal, connect with this terminal, and to avoid any spark inside in the motor, just go for a capacitor, CAP, capacitor with the generic capacitor. Generic, where is generic? Sorry, here you find the generic. So there is no generic here. No. CAP is CITO capacitor, animated or generic. Here we find the generic non-electrolytic type, and same as again plus on the keyboard, place here, and make the value. If you are using a 12 volt with low current, then go with the 0.1 microfarad of current, just to avoid the sparking in between the motor brushes and their contact points. So here we got the negative connection at this terminal, and same as like this must be connected with the positive terminal. Okay, connect this with the positive terminal, same this with the positive terminal, because motor is of 12 volts and 12 ohms. We have to put the potential of 12 volt here as a source. So this circuit is completed. To operate this circuit, what you have to go with, either you have to attach some type of switch or IC or microcontroller to trigger this circuit. Okay, to operate these relay, the resistance is nearby 240 ohms. So maybe because same as also the 12 volt is there, so there is no any type of microcontroller, not exactly the same as there is no any type of microcontroller is there, but generally we are using a 8051 controller or type of AVR or Arduino Uno. So same as like in Arduino Uno, you will get the output of positive supply as a 5 volt positive and 0 volt as a 0, means it is ground. So whenever the output is 5 volt, then the current at the pin is nearby 10 milliampere because the internal resistance applied on it. So to amplify this, we have to switch or apply the IC of ULN 2003 or 2803. So we will go with the ULN 2803 and place it here, and the common, you have to leave the common pin and connect this pin with one coil. For sake of clarity, I'll go drag it, and this thing is connected here. So go with the logic state and connect with the first and second logic state with the pin number 2. 1B is having an input, then output is 1C. For 2B is 2C. So okay, just go for with the play button, just play it. Now you can see if 00 is output and there is no output getting from the IC. So because it is active low, so whenever we'll get the positive input to the IC, means from a microcontroller, whenever there is a plus 5 volt of potential having a current of 10 milliampere to the IC ULN 2803, it will output with the result of 0. Means this is not a state, not a higher state, it is gray, you can see. So the relay will not work. So now I'm pressing the button. Now you can see the at pin number 18 it will getting blue because of one. When I press the another one, same as like pin number 2 is high and the result is low. So both relay are on. Because these two are on, from here you can see the motor get negative. For the sake of clarity, I am going for voltmeter, DC voltmeter here, and one end is connected to there, another is there's no matter, you can switch these terminals with the another terminals of the motor too, because it will go with the negative and positive potential also. Okay, so same as in a circuit, these are two getting 1 in position, and when I put for 0, it is moving in a clockwise direction. And same as like if it is in 0 state, then for in a whole circuit that is only a positive supply, so there is no reference potential across the motor, so it will not run. Whenever there is any change and consequent change in the input signals, it will start rotating accordingly, clockwise and anti-clockwise. Now it is running anti-clockwise with potential of 11.8 volt. Okay, so we can also check by applying ammeter circuit, ammeter meter, amps meter here, and you know that amp meter is connected in series always, so it will show the current draw through the motor. Just play it, 0.98 and 11.8 volt. Okay, so just check with the calculator. VLC minimize, sorry, not minimize, go for, because you know in Ohm's law V is equal to IR, So I need to check the resistance. Then V upon I is equal to R. So 11.8 divided by 0.98. 0.98, that is 12.040. So this 12 is a total resistance of the circuit, or that is required by motor. Nominal reverse, that is 12 ohm. Okay, if I go for 24 ohms in a circuit and play, then 11.9 volt and 0.50 ampere. Just go calculate, minimize, not exactly minimize, and go with this 11.9 divided by 0.5. 0.5, that is 23.8, near equal to 24 ohms. So same as like these relays are having a great capability, or you can search at Amazon and search with the relay, RELAY SPDT single pole dual throw. So these are the relays. Let's check their current. Here you can see, but by hovering I can't find another. Check by another one. Okay, this thing. Okay, so now you can see it will work with the 10 ampere 240 volt and 10 ampere 125 volt AC, same as like 10 ampere 28 volt DC. The coil will work up to a 24 volt DC, but you can also go with bit lower potential. But if you are going to buy a relay, this type of relay, just go with the specification. This relay is 24 volt and we are required here a 12 volt. You can go also with the specification of 5 volt relay too. 5 volt, just check it. So here you find SPDT. This is the one. Okay, you can see 10 ampere 250 volt AC for a connection. Means these are the pins where you can connect with the 10 ampere 220 volt AC, and also 10 ampere 28 volt, 10 ampere 125 volt, and 10 ampere 30 volt DC too. Okay, but this coil is with 5 volt potential. Okay, so in this circuit, these type of circuits are having an internal rectifier. This thing can be directly connected with the microcontroller. You don't even go with the extra circuit like in a circuit we have. This thing is not required. Directly connect those pins with the relays, so it will work. So for this circuit you have to go with you have to go with 12 volt these type of relays. So up you can see S10 volt, blah 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 blah. Okay, if you want to buy these relays and the rest of the components from the market, these relays, ICs, motor, or not exactly these voltmeter things, I'll provide this thing in our description below. You can check in my video, and hope this will work for you. Okay, keep in touch with us. Hope you like this video, and what will be the next video, please comment below. I'll surely go with the solution. Bye bye.